In northern Mexico, on the night of February 8, 1969, the sky over Pueblito de Allende tore open. Witnesses described a fireball brighter than the moon, screaming across the darkness before shattering into thousands of pieces that rained down over 60 square kilometers. Farmers found smoking black stones scattered through their fields. Scientists arrived within days, and what they discovered inside those stones would rewrite everything we thought we knew about our own planet's birth. Buried within the Allende meteorite were tiny white flecks, no larger than grains of rice, that turned out to be older than Earth itself, and among the oldest solid material ever found in our solar system. They were fragments of the material that existed before the planets formed at all. Before Earth, before the moon, before you had a rock to stand on. Everything that exists has an origin. Yet ask most people how Earth came to be, and the answers grow vague fast. Something about dust, something about time, something about the sun. We live on this planet every day of our lives without ever really knowing how it got here, or what violence it took to build the ground beneath our feet. So how do you reconstruct the birth of a planet that spent 6 billion years erasing the evidence of its own beginning? By the end of this story, you'll understand how scientists pieced together Earth's birth certificate from fragments scattered across the solar system. You'll learn why the planet you're standing on may owe its very existence to a collision that should have destroyed it completely. And you'll walk away seeing the ground beneath your feet in a way you never have before. To grasp how strange Earth's origin really is, picture the solar system before it existed at all. Not as planets, but as a single flattened disk of gas and dust, collapsing slowly under its own gravity around a newborn star. Inside that spinning disk, particles finer than flour began colliding and sticking, building pebbles, then boulders, then bodies the size of mountains. Within a few million years, and multiple Mars-sized planetary embryos were crashing through the inner solar system on unstable orbits. Earth, in its earliest form, was not a place. It was a demolition derby. And Earth's most important moment wouldn't come from quietly assembling out of that debris. It would come from the day another planet nearly destroyed it. A collision we'll return to, because so much about the world you live on today traces back to it. But first, the evidence for this violent beginning doesn't come from Earth's own rocks. And that fact alone should surprise you. Earth has been resurfaced so many times by volcanism, tectonics, erosion, and impacts that almost nothing survives from its formation. So scientists had to look outward. Meteorites like Allende, which never became part of a planet, act as frozen time capsules, largely preserved since the solar system's infancy. In the 1950s, geochemist Claire Patterson used the radioactive decay of uranium into lead within these meteorites to calculate an age for the solar system, and therefore Earth, of approximately 4.55 billion years. A figure that has barely moved since. But Patterson's work led to an unsettling discovery of its own. To get an accurate reading, he needed lead-free environments, and he couldn't find one anywhere on Earth. Air, water, food, even rainwater collected in remote locations, all carried trace industrial lead contamination. Patterson's search for Earth's birthday accidentally exposed a global poisoning crisis from leaded gasoline, one that would eventually lead to its ban. The man who dated our planet also helped save it. An age, though, is not a birth story. To understand how Earth actually assembled, scientists turned to a mineral almost too small to imagine: zircon. In the Jack Hills of Western Australia, geologists found zircon crystals dated to 4 billion years old, among the oldest known fragments of ancient terrestrial material, forming while the planet itself was still remarkably young. Trapped inside these crystals were oxygen isotopes, suggesting something remarkable. That liquid water may have existed on Earth's surface far earlier than anyone expected, potentially while the young planet was still being pummeled by debris. The image of early Earth as a molten, hellish wasteland, which is exactly why geologists call this era the Hadean, after the Greek underworld, may not tell the whole story. Some patches of that hell may have had oceans. And that's where the story takes its strangest turn, because those oceans, that crust, that early water, were all about to face a catastrophe that would reshape the planet completely. For decades, the assumption was that Earth simply grew, layer by layer, into the world we recognize. But evidence from the moon suggests something far more catastrophic. Around 4.5 billion years ago, A Mars-sized planet, one astronomers now call Theia, is believed to have slammed into the young Earth at an angle, in a collision violent enough to melt and vaporize vast portions of both worlds. The impact hurled a ring of debris into orbit, which is thought to have coalesced into the Moon over a remarkably short span of cosmic time. Earth, meanwhile, absorbed the rest of Theia into itself. This means that a portion of the ground beneath your feet right now may have originated from a planet that no longer exists, annihilated into the body you're standing on. And many researchers believe the impact tilted Earth's axis and left the young planet spinning far faster than it does today, with days only a fraction of their current length. That moon now drives Earth's tides and over deep time is thought to have helped keep Earth's axial tilt relatively stable, the tilt that gives us our seasons. Even confirming that Earth had an age took science down strange paths. Lord Kelvin once calculated it from the planet's heat loss and landed on a figure of just tens of millions of years, far too short for Darwin's theory of evolution to work, simply because he didn't yet know Earth generates its own inner heat through radioactivity. It took decades to correct him. Older traditions, long before any of this science existed, told the story in thousands of years rather than billions, not out of ignorance, but because that was the only scale the human mind was ever built to hold. Zoom out far enough, and Earth's formation stops being just a planetary story and becomes a story about why anything is alive at all. Earth formed at a distance from the sun where liquid water could persist. Not so close that oceans would boil away, not so far that they'd freeze solid. But distance alone wasn't enough. A violent bombardment of asteroids and comets that pounded the young Earth and Moon alike. Leaving the scars still visible on the lunar surface tonight may have contributed significantly to Earth's water and organic material. The chaos that could have sterilized a young planet may have been part of what made it livable. Today, this exact detective work, reading isotopes, modeling collisions, tracing chemical fingerprints across billions of years, is the same toolkit astronomers now point at distant exoplanets, asking whether other worlds followed a similarly improbable path toward life. So the next time you feel solid ground beneath your feet, understand what that ground actually is. It isn't ancient in the way a monument is ancient, sitting untouched since it was built. It's ancient because it survived. A planet, a moon, and a collision that by every reasonable measure should have ended before it began. Earth was never simply created. It was assembled, wounded, and rebuilt, one collision, one correction, one accidental discovery at a time. And somewhere in the iron beneath your feet, in the water in your glass, in the very tilt that gives you seasons, a world that no longer has a name is still part of the one you call home.